Welcome to our video tutorial on Kubernetes components. We will be presenting Kubernetes architecture and different components. The first construct of Kubernetes is clusters. Clusters are physical segregation where resources in a cluster are not shared with the other clusters. Within a cluster, we have the master node. It's responsible for maintaining the desired state, scheduling applications and scaling them. The master node contains all the control plane components responsible on the well-functioning of the Kubernetes cluster. Worker nodes, on the other hand, are responsible on running containerized applications. The worker node can be a bare metal server or a virtual machine. Each worker node contains the resources necessary to support container runtime that run the applications such as Docker, CRI-O, Containerd, etc. Containerized applications are deployed through pods, form factors. A pod is the smallest deployable unit that can be created and managed in Kubernetes. A pod can contain one or more containers, usually designed to work together. The API server as a part of Kubernetes control plane, it functions as the intelligent proxy through which all interaction with the cluster's state occurs, exposing the Kubernetes API for both internal and external users. It handles RESTful requests for CRUD, create, read, update, delete, operations on cluster objects like pods, services, and deployments. By doing so, the API server plays a pivotal role in maintaining the cluster's desired state, while also providing a means for other control plane components, like the scheduler and controller manager, to interact with the cluster. The scheduler in Kubernetes is a control plane component responsible for assigning newly created or unallocated pods to suitable nodes in the cluster. It does this by evaluating various factors such as resource availability, node conditions, and user-defined constraints. Once a decision is made, the scheduler updates the pod's information in the Kubernetes API server, triggering the pod to be placed on the selected node. This automated scheduling process is essential for optimizing resource utilization and ensuring the efficient operation of a Kubernetes cluster. The controller manager is a critical component responsible for running various controllers that regulate the behavior of the cluster, ensuring that its current state matches the desired state defined by objects in the Kubernetes API. The controller manager manages various aspects of nodes, such as observing newly registered nodes or taking action when nodes become unreachable, ensures the desired number of pod replicas for a service are running at all times. While existing workloads may continue to run, the loss of the controller manager would mean losing the automated management and scaling capabilities of the cluster, putting an operational burden on the system administrators to manually handle these tasks. etcd is a database providing a reliable way to store the configuration data that defines cluster state. As a critical component of the Kubernetes control plane, etcd ensures data consistency and high availability through replication across multiple nodes in the cluster. Kubernetes components interact with etcd primarily through the API server, which reads from and writes to etcd to maintain the actual state of the cluster in alignment with the desired state specified by Kubernetes objects. If etcd is down, the Kubernetes cluster will enter a non-operational state that impacts both existing workloads and the creation of new workloads. Deployment is a blueprint that describes how to create and update pods. It ensures that a specified number of identical pods are running at any given time, handling updates and rollbacks automatically. A service, on the other hand, is a way to expose these deployments to the outside world or to other parts of the same cluster. Service can act like a proxy, or sometimes like load balancer to access the constantly changing pods, directing network traffic to the right pod instances. Finally, namespaces are a way to divide cluster resources between multiple users. It is logical and organizational segregation that can be used to split between applications, department, and teams.